Okay, I want y'all to think back to day one, the family tree of quadrilaterals, and if you have it, you can take it out and look at it. In quadrilaterals, you have two basic types. You have parallelograms and trapezoids. We'll talk about trapezoids tomorrow, but within parallelograms, you have rectangles and rhombuses, and I want you to think about like your family tree. Basically, what's happening is if a rectangle and a rhombus came together and had a baby, it would be called a square. Basically, this last parallelogram we're going to talk about with squares, squares have everything that all the other parallelograms have, because a square is a rectangle, a square is a rhombus, and a square is a parallelogram. Okay, why? Because if opposite sides are parallel, okay, that means it's a parallelogram, and all four angles are congruent, that means it's a rectangle, and all sides are congruent, that means it's a rhombus. What you have is a square. Okay, so opposite sides are parallel, all four angles are congruent, and all sides are congruent. So basically everything we've learned about all of those apply to a square. So it says since a square is a rectangle, its diagonals are congruent. So my question is, what about the diagonals, right? Here's the sides, here's the angles, cool. What about diagonals? So since it's a rectangle, they're congruent. Because it's a rhombus, they're perpendicular. And honestly, because it's a parallelogram, they're also going to be bisectors. Therefore, okay, I'm just going to summarize it in one quick statement. The diagonals of a square are congruent, perpendicular, bisectors. Remember, the diagonals of a square also bisect the angles since it's a rhombus. So the diagonals are congruent, the diagonals are perpendicular, and the diagonals bisect each other. They also bisect the angles in the corner. All right, well, think about a square for a second, okay? If I have 90-degree corners and I draw in a diagonal and I just bisected the corners because it says that the diagonals bisect the angles, what is half of 90? Okay, 45. So all of these little angles right here are 45 degrees. Will that ever not be true? No. So in a square, all four angles have to be 90 degrees because all of the angles are congruent. And if the diagonals bisect the angles, that means this is always true in all squares. If I'm cutting the corners, so like in this square right here, I have an X, and it's asking for the angles, I know that all the way around is 90, in the middle is 90, and all of these little pieces right here have to be halfsies of 90, which is 45. So we need to review something really quick before I even go to the examples, because if you don't know this, you're going to be really confused. I'm going to need to find some segments in a second, and especially in this picture. I don't really have a whole lot, and in this one either. And so we need to review something that I don't want to go down a big long rabbit hole, but basically in Math 2, you guys learned how to find sides of right triangles if you only knew one side, and angles. And it was SOHCAHTOA, right? Sine, cosine, and tangent. But then you also were hopefully taught, whether you remember it or not, you were hopefully taught special right triangles. So there's two special right triangles, 30, 60, 90s, and 45, 45, 90s. So that's what we have in these pictures. If I cut my square into a bunch of little triangles, I'm going to have a whole bunch of 45, 45, 90 triangles. So let's come over here really quick and talk about that 45, 45, 90 relationship. Y'all just need to take this note and study this. It's so easy if you can just remember it. So I did a really bad job, but remember in a square, these two sides are congruent. And so what you end up having is a 45, 45, 90 triangle, right? If this is 90, these angles are 45 degrees. Okay, so these two sides are the same. So your teacher either called those sides 1 or called those sides A. And if you do sine, cosine, and tangent over and over and over and over again, you would have found that the relationship is always, if these are A or 1 or whatever you want to let it be, to get to the hypotenuse, you multiply by the square root of 2. An easy way to remember that when I used to teach math 2 is I taught them in a 45, 45, 90, two of the sides are the same, so you multiply by the square root of 2. Because in a 30, 60, 90, it's like the square root of 3. That's in that triangle. So when I go to find these sides, I just need to multiply or divide by the square root of 2 to get that answer. So let's start with segments in a square. They're all the same on the outside. So if that's 9, 9 all the way around. Okay, so what I have here is a bunch of 45, 45, 90 triangles. So it says find each angle. I'm not going to write it in. I'm going to draw it in. This is 90, this is 90, this is 90, and that's 90, right? The reason is because the diagonals are perpendicular. So the diagonals are also congruent. So this side's congruent. This side and this side's congruent because they bisect each other, and this side's congruent. So these diagonal little pieces are all going to end up being the same. I just need to figure out what they are. Well, my special right triangle said these are all 45, 45, 90s. We know that's going to always be true. So that means that these two sides are the same, and this side is these sides times the square root of 2. So these little pieces right here are 9, and if we're going backwards, we're not multiplying by the square root of 2, we're dividing by the square root of 2. And this is going to get kind of messy. You also hopefully learned in math 2 that you will never see an answer choice like that on like a test or like a multiple choice type situation because square roots cannot be in the bottom. The way you get rid of that is you do what's called rationalizing the denominator. Last year I made this extra credit. Getting rid of the radical in the bottom is simplifying the answer. So if you see that on your test, like extra credit, simplify your answer. To get rid of this, I'm going to multiply by a fancy 1. I'm going to multiply by the square root of 2 over the square root of 2. The reason why I'm going to do that is because the square root of 2 times the square root of 2 is the square root of 4. And what's the square root of 4? 2. So I won't have a radical in the bottom anymore. So 9 times the square root of 2 is 9 square root of 2, but these radicals cancel and you just have 2. So this is called rationalizing the denominator. This is simplifying your answer. My picture's getting kind of messy. I'm not going to do them all. Just don't forget that these little angles right here are all 45 degrees. And that's going to always be true. So in this next picture, I have another square, you guys. All these angles right here are 90. And all of these angles, little angles in the corner, they're all 45. 45, 45, 45, 45, all the way around. It's just going to kind of look kind of messy. Okay, but squares are so boring because, like, everything's just the same. And that makes it easy if you guys study this. So you really need to study this right here. Okay, this is from Math 2. I'll be back before the test, which will be great for some of you guys who need me to explain this in person. But y'all, 45, 45, 90, study this. The sides are the same, and the hypotenuse is times the square root of 2. If you're going backwards, you divide. So in this picture, I know this is 7, and I know that this is congruent to this, which is also congruent to this, which is also congruent to this. So all of these little pieces right here are 7. All right, so this time I have like my A. This is 7 and this is 7. So what's the hypotenuse? Well, it's just 7 times the square root of 2. Just that easy. You don't have to do any solving or anything crazy. Okay, so speaking of that, you guys are going to do the practice for homework. You do have some solving, so it'll say like, if this angle equals 10x, solve for x. Just remember, a lot of your angles are 90. A lot of your angles are congruent because like they're being bisected and things like that. So look at your boxes, do your practice. Tomorrow we will wrap up this unit, you guys, with trapezoids. You'll have a couple of days of review and then test.